Okay, so here we are for part 2. Hopefully you already watched the first video on evaluating logarithms using a number line. And now this second video is going to talk about, okay, well, what if it is not a perfectly packaged problem and the number I'm trying to land on isn't on my number line? So here, as we mentioned earlier, this base of 6 means that I am making my number line multiplying by 6. So I'm going to start my number line at 1, and I'm going to multiply by 6 to go to 6. And then next would be 36. And then next all the way up here would be 216. And if I went the other way, right, it would be 1/6, 1 over 36, and so on. So I'm trying to get to 40, and 40 is not on my number line, but I'm going to place it somewhere about here. It's closer to 36 definitely than 216, but it is not on my number line exactly. So here is where we are going to estimate. These problems are really more about an understanding of what logarithms mean than about finding the correct answer. So log base 6 of 40, if I'm evaluating that, it means I made my number line going by 6s and I'm trying to land on 40 and I'm trying to figure out how many jumps there are. Well, I always start from 1, remember, when I start jumping. So 1 jump will get me to 6, 2 jumps will get me to 36, 3 jumps will overjump me to 216. So I'm going to estimate that log base 6 of 40 is a little more than 2 jumps, and it's actually really close, right? 40 is really close to 36. It's not halfway between 36 and 216. 40 is pretty close to 36, so we're really just estimating. I'm going to say it's about 2.1 or 2.2, because just a little past 36, right? 2.5 is going to get me too far towards 216. So when you're estimating, we're not looking at a perfect answer, but I'm expecting something to be more than 2, but less than 3, and way closer to 2, because 40 is a lot closer to 36 than it is to 216. If we had the same problem and it was like log base 6 of 200, well then 200 would be a lot closer to 216. So here I would say it'd be more reasonable to say 1, 2, and I'm going to take almost 3 jumps. I'm just going to be just shy of 3 jumps. So I would probably do something bigger like 2.8. But again, we're just estimating. It doesn't need to be perfect. We're actually going to talk later down the road how to find an exact answer. But for right now, we are estimating. And for this second example, I would expect to see a number slightly less than 3 jumps. And for the original problem, this first example, I would expect to see something just slightly more than 1 jump. Okay, so we can repeat doing the same thing. Here I'm using a base of 3, so it means I'm starting my number line at 1, and then multiply by 3 is 3, multiply by another 3 is 9, multiply by another 3 is 27, could keep multiplying by another 3, could go this way, but I don't need to do that because 25 would be right about here. So that means to get to 25, starting from 1, I'm going to take 1 jump, 2 jump, and I'm going to almost take 3 jumps, but if I take 3, it'll get to 27. Instead, I'm going to be slightly less than 3, so maybe I'm going to say it's 2.8 or 2.9 again. Again, just estimating, just making sure if you put 2.1, that would not be right because you would be closer to 9. So we want to clearly be closer to 27, so we're closer to 3 jumps, so an estimate of 2.9 or 2.8 would be closer. If you wanted to check and see how close you were, again, we're going to learn how to find the exact answer. But a way you could check for now is, remember, this has a connection to exponents. 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. So basically we're guessing about 3 to the 2.9 would be 25. So if I take out my calculator and I do 3 caret 2.9, 3 to the 2.9 power is actually 24.19, so I'm pretty close to 25. Again, you don't need to do that. I don't need you to pull out your calculator. If you had said 2.7, 2.8, 2.9, all of that would have been fine as long as it's clear that you realize it's closer to 3 jumps than to 2. And then for our third example here, we're starting at 1. Remember, we talked about how in the last video, if there's no base, it doesn't mean the teacher forgot it. It's assumed the base is 10. So 1 times 10 is 10, 10 times 10 is 100. 100 times 10 is 1,000. So I'm trying to go to 900, right? So 900 would be close to 1,000. So again, that would mean 1, 2, 3 jumps is too much. So I want to do slightly less than 3 jumps. So again, I'm going to say 900 is a little bit farther away from 1,000 than 25 was to 27. So I'm going to say about 2.8. So that is what we're expecting when we have you estimating logarithms. Again, I prefer you not to take out a calculator. I prefer to see number lines and jumps, and for you to understand that we're saying 2.9 jumps by base 3 would get you to 25. 2.1 jumps by base 6 would get you to 40. And just an understanding of, even if it's not exactly on the number line, I can estimate where it is. And this is going to be helpful when we get to this next problem, which is ordering from least to greatest. All I'm doing is ordering from least to greatest here. I'm not finding the exact answers. So for some of these, I might be able to find an exact answer, and for some of them, I might have to estimate. But then I'm going to put them in order from least to greatest based on how many jumps it took. So the thing I'm putting in order is, what do I get for my answer here for each of these, which is trying to figure out how many jumps it is. And once I figure out how many jumps it is, I'm going to put them in order from least to greatest based on how many jumps it took. So for each of these, you can make a number line if it helps. So for this one, I'm making a number line going by 6 because that's my base. And I'm trying to get to 6, and getting to 6 would take me 1 jump. So I'm going to keep that 1 in mind when I go to put them in order from least to greatest. I'm going to go across this next one here. This is the only fraction I have. And remember, fractions are negative jumps, and negative would count as least. So I bet this one here is going to be the lowest I have. So say I make my number line, I'm starting by 1, and then I'm going by 9. So 9, 81. But I want to go this way, so I'm going to have 1/9, 1 over 81. So that's going to take me 2 jumps to the left, so that's going to be -2. So right now, -2 is my least, and I'm not going to have any lower than that because I have no other fractions, so I have no other ones going to the left. So right now I'm going to put c, logarithm c, as my smallest one because logarithm c has a value of -2, and there's no other negative ones on there. Okay, let's keep going. Here, so for this one, I'm going to make my number line starting at 1 and going by 8s. And I want to get to 64, which is 2 jumps. So there I have 2, which is bigger than 1. So right now I know E is bigger than A. Let's keep going to see what else we can learn. Here, I'm starting with 1, I'm going by 7. So 7, 49, 243. And I'm trying to get to 10. Wait, 10's not on here. 10's like one of the ones we just did, right? We're going to estimate. So 1 jump would get me to 7. 2 jumps would get me to 49. 10 is a lot closer to 7, so I'm going to say it's 1 jump and a little bit. So I'm going to estimate 10 at like 1.2, just a little bit more than 1, right? So A was 1 clean jump, whereas B is 1 clean jump plus a little bit to get me to that 10. And now for D, I'm going by 5s, so 1, 5, 25, 125 when I multiply by 5s. And again, 29's not on here, but 29 is going to be a lot closer to 25 than 125. So this is going to take me 2 jumps, isn't going to be quite enough. I'm going to need a little bit more. So I'm going to say this is 2.2. So notice, and this is kind of what the problem's getting at, A, B, D, E, they're all around 1 to 2. But this one's 1, this one's a little bit more than 1, this one's 2, this one's a little bit more than 2. So then I'm going to go to my one last one, natural log. We haven't done as many of these, but remember, a natural log means the base is e. So I'm starting with 1, and then 1 times e is e times e is e squared, and so on. And I'm trying to get to 1. Well, if I start at 1 and I'm trying to get to 1, that means I'm not going to jump at all. So I'm going to take 0 jumps. So right now I have answers for all of them, and now I'm going to order them. So C was my only one with negative jumps, so that was my least. Then F has 0 jumps, so that's going to be my next smallest. And then now I just need to be careful for the next ones. So this one's 1, and then after that a little bit more than 1. And then this one was 2, so E, and then this one was a little bit more than 2, so D. So now I put all those logarithms in order from least to greatest. Hope that was helpful. Let us know if you need anything else. Bye.